My name is Kyla Levin. I did this work with my colleagues here at UMass Amherst as well as at Williams College, but all the work was primarily done here at UMass. So I don't know if any of you guys know this, but in 2007, Disney made this really good movie called Ratatouille. And in case you haven't heard of it, it is this movie about these two very different chefs who kind of come together to achieve greatness. And so today we're going to talk about two different programmers who can do the same. So let's meet our first one. So this is Linguini. He is this aspiring chef, and he recently got this job at this fancy gourmet kitchen. And he's very much like a beginner programmer because he's just getting started. He doesn't know his way around yet, and sometimes he can make some mistakes. Sometimes he gets a little in over his head, and he messes up his code, and he breaks things, and his dishes don't really turn out very good. So when you make mistakes and your recipe doesn't turn out good and your code doesn't work and you don't know why, what do you do? Programmers, we would try to use debuggers. That's kind of our go-to tool for these sorts of problems. So that's what Linguini should probably do, right? Is try to use a debugger. I'm seeing that the GIF isn't really working with this latency, but we'll pretend it works. But using debuggers is a little easier said than done sometimes. So when you open a state-of-the-art debugger, this is what most programmers are going to see, an interface that looks something like this. And when you first are met with this is a lot of information to take in. Unless Linguini's already familiar with this whole debugger and the interface that comes with it, and he has a lot of prior experience using that, it's a really difficult and arduous process to quickly and efficiently identify what information in this UI is relevant to his bug and how that's going to lead to an actionable fix for him. And so it's kind of like being stuck in this really big kitchen, right? You know that it's full of tools that you've seen professionals use before, but unless you as the young programmer or chef already know how to use those tools, learning how to is going to be a very non-insignificant amount of time and effort. And so getting started without any sort of initial guidance can feel completely impossible. And so by comparison, this is what Linguini is going to see if he tries to use a command line debugger, or even something like a debugger in a Python notebook. And so this is way worse, right? We don't really have any information here at all. You don't have anything to go off of, nothing to tell you what to do next. And so it's like being in the same kitchen, only now it's like somebody turned off the lights. So you're just kind of left fumbling around in the dark. And if you have all these challenges and no real obvious way forward, how are you, as a programmer, supposed to fix your buggy code? Well, what happens in the movie is Linguini's cooking always gets fixed by this rat named Remy. And Remy is this master chef who can actually turn any failed dish into like amazing masterpieces. But he's a rat. He's not really welcome in kitchens, so he can't really cook by himself. So wouldn't it be nice if we as programmers had something like Remy to help us? Wouldn't it be nice if we had somebody, this expert, who could just come in and knows exactly what to do and fix your mistakes for you? And that's where ChatDBG comes in. So in the movie, Remy helps turn Linguini into this world-class master chef by kind of controlling his motions. And all Linguini needs to do as the amateur is sit back, relax, and let Remy take over everything from behind the scenes. And so ChatDBG is this advanced debugging assistant that can take over the debugging process and work together with beginner programmers to find and to fix bugs. So we're going to start with a little demo. We're going to see ChatDBG in action. We'll give a very high-level overview of the system of ChatDBG and how it works. We'll talk about the short little suite of functions that ChatDBG uses to actually debug. And we'll talk about a few security concerns that raises, as well as how to mitigate them. And then we'll end with how we evaluated it. Sorry. So before we talk about how it works, let's actually sit back and watch ChatDBG cook. So we have this Python program here, and let's say some beginner programmer wrote it, and we'll just call him Linguini. Now, there's a pretty big problem in this program. If we run it through PDB, we can see that this assertion is failing. We can see that these two expressions are supposed to have the same value, but they clearly don't. So what are we supposed to do? Well, don't panic. We have ChatDBG. So ChatDBG can answer any natural language question that you want, but for now, we're going to stick to a very simple, very basic question of just why? Why is this happening? And just like how Remy guides Linguini around by kind of pulling on his hair, once we ask ChatGPT why, it then harnesses the LLM to go off and try to start the debugging process. And so all this text in purple is text that's being generated by the LLM. And the yellow blocks here that are outlined in red, those show the LLM requesting more information from the debugger about the program. And so we can see in the first block, it's searching the code for additional context about relevant functions that it hasn't seen before. And we can also see that it's trying to navigate through stack frames using the up and down debugger commands. And so it does a bit of more thinking. And then at the end, what it provides us with is a correct fix for our bug, as well as a bit of explanation around what the problem was. And from there, the conversation window reopens, and we as the user are free to either exit and go and apply the fix and see if it worked, or if we're not happy with the suggestions, we can continue conversing with ChatDBG to try and get something better. So we know that the rat is actually the one behind everything that's driving. But how does ChatDBG actually work? Well, let's think back to our traditional command line debugger. So to use this debugger, Linguini already needs to be familiar with the interface of this kind of obscure tool. He needs to know the exact set of arbitrary commands that it recognizes, and he needs to know exactly how to use those commands in order to retrieve all of the relevant code context about the program himself. And so again, just like being in that big kitchen, lots of tools, no idea how to use them. So instead of being constrained to this set of arbitrary commands, what Linguini really wants to do is just be able to ask the real question directly, which is just, why is my program crashing? Or why isn't the code doing what I think it should? And so ChatDBG allows us to ask these questions directly from the debugger interface. It then makes a call to the LLM, asking it your question and providing it with some initial information about the program that is gathered from the debugger. So this includes the error message, as well as something that we call the enriched stack trace. So what is the enriched stack trace? Well, it's the same as an ordinary stack trace, but ChatDBG is going to assume that if Linguini has a bug in his code, the bug is probably in the code that Linguini wrote. So the enriched stack trace omits any frames of library code. It also includes a little larger context around each line for each frame, and a short summary of all of the global and local variable values from each frame. And so now, equipped with this information, the LLM is then free to go off and generate its own explanation and fix for Linguini's bug. And a key feature of this process is how the LLM can send commands directly to the debugger. And this allows it to dynamically gather context about the program that it wouldn't normally have access to if it was just allowed to examine the source code. But it's context that it can discover through the abilities of the debugger. But no chef can really work efficiently without being first given the appropriate tools. And so, what tools make ChatDBG a good chef? Well, the main feature that makes ChatDBG's agentic approach possible is this function calling ability of modern LLMs. And so it's essentially where you provide the LLM with this list of functions, and it can then call any of those functions at will. And so the primary function that ChatDBG uses is this function that we call debug. And the LLM calls the debug function whenever it wants to execute a specific GDB or PDB command. And so it gives it the name of the command as well as any arguments that the command might expect. ChatDBG will then go off and execute the command in the debugger. It will collect the response, and then it will feed that back to the LLM. And so, for example, if the LLM wants to print the value of some expression, it might run debug print, or it might try to navigate stack frames using debug up, debug down. But by itself, the debug function isn't really enough for ChatDBG to completely do its job. And so the LLM often needs this kind of shorter, faster way to perform really common code operations. And so these actions could theoretically be done by the LLM alone, but it would require the LLM to do this very long, tedious traversal of potentially very many files and directories in search of the information that it needs. And so it's kind of like giving the LLM this little cookbook, this very helpful compilation of convenient recipes that ChatDBG can then provide the LLM with. And we can see some of these functions here. And so the definition function in particular is for finding variable definitions in C and C++, and it does this through integration with the ClangD language server. And so this is just one example of how the ChatDBG can be extended to utilize other external tools that can better facilitate its abilities. Now, sometimes blunt knives don't really get the job done. And so slice is one function that we provide ChatDBG that's a bit more precise. And so the slice function is specific to Jupyter notebooks. It is somewhat needed because unlike conventional scripts, Jupyter notebooks contain these independently evaluated cells. And they can make it really difficult to reason about program behavior. And so what the slice function does is it gives ChatDBG this added ability to examine the source code in the backward slice of any global variable that was previously defined. And so this really expands ChatDBG's ability to explore code from previously executed cells. So we've talked a lot about all the really cool things that ChatDBG can do. But let's not forget that at the end of the day, we are allowing rats into the kitchen. So how do we stop them from kind of getting out of control and just running wild and not having any human oversight at all? Well, it's okay. ChatGPT has a number of safeguards in place for exactly this purpose. So the first very line of defense that ChatGPT has is it runs in this default safe mode. And in safe mode, the LLM cannot run any debugger commands that are not on a user-defined whitelist. And so if you don't trust the LLM to read from certain files, then you don't have to let it. But if you do, then you can always just turn that off and you can give it an unsafe flag and you can let it go at your own risk. And sandboxing is, of course, always a good way to prevent the LLM from doing any real serious or wide-reaching damage. And then finally, ChatDBG isn't actually changing your source code directly. The LLM at the end of the day is just producing code suggestions, and it's up to you as the human user to apply those and then run your code with them. So with all of these additional features and abilities, we have seen that in fact ChatDBG can debug. But let's evaluate how good it actually is at this. So we evaluated ChatDBG in two very different settings. The first was this ablation study that we did on a set of 22 Python student programs, and these were taken from two different introductory computer science classes. And then the second was a test of these 8 real-world applications in C and C++, and ChatDBG performed very well on both of these suites, but today we're going to focus on the ablation study in Python in particular. So here's a screen that looks familiar to some people. So how does ChatDBG compare to just this ordinary conversational ChatGPT window? So good news, we tested that. And so the very first configuration of our ablation study was collected by running ChatDBG on each of these student programs with no enriched stack trace or function calling enabled. And so these student programs were a mix of Python scripts and Jupyter notebooks, and each of them had a bug. Each of them was run through ChatDBG, and across these 22 programs, the average success rate for ChatDBG finding and fixing the bug correctly was only about 20%. And since in this configuration, the LLM can't call any functions and it didn't use any sort of enriched stack trace, this default stack configuration, as we call it, is the moral equivalent of just copying and pasting your error message into ChatGPT and then giving it the Python default stack trace. And so we can see that it solves some problems. It's not completely helpless. But by default, each frame is only given a couple lines of code as context in each of the frames. So this isn't really a lot of information for the LLM to go off of. However, when we use ChatDBG's improved prompt, which includes the enriched stack trace, and we factor in our tiny chef who can lead this agentic code navigation process, This ability to explore the program space makes ChatDBG's success rate increase to about 57%. But keep in mind that we're still only asking the LLM this very basic why question. So that's why this configuration is called just why. So now let's consider our human developer. If Linguini runs into this bug, maybe at first he's really tired, he's really exasperated, and all he wants to know from ChatDBG is just why. And that's what happened in our demo. But what this means is that ChatDBG is being given this very basic instruction that pretty much just says, hey, there's a bug somewhere, go find it and fix it. If Linguini really wants to debug its program, he's probably going to ask it something a little bit more specific, something that actually relates to the program's observed behavior, such as like, why is this array a length 5? Why is x a null pointer? Something like that. And when you ask targeted questions like that, ChatGPT's success rate jumps up to 67%. And this is how ChatGPT reintroduces the human back into the developing process. Furthermore, ChatGPT still allows you, as the human, to converse with the LLM the exact same way that you would in a conversational window. And so when ChatGPT is done and it's done all of its exploration and has either proposed a fix or maybe given you some debugging recommendations, if you just provide it with this very generic follow-up that just kind of says, continue to explain your reasoning and give me a fix, that alone is enough to further increase ChatGPT's success rate to the full 85%. So as you can see, each component of ChatGPT, including the human developer, contributes to its overall debugging efficiency. And so these last two configurations of ChatGPT in particular demonstrate to us that just as how rats can cook, ChatGPT can also debug. But neither of them do it quite so well as when they're paired with their human counterparts. So maybe humans and rats together can cook, but just as ChatGPT does all of its best debugging when it keeps the human in the loop. So what have we learned today? To paraphrase a great chef, not everyone can debug, but great debugging can come from anywhere. ChatDBG is available for download at the following link. We welcome any and all feedback on it, and thank you for your attention.